Perfect. So yeah, as a quick way of introduction, Brian Mathews, I'm a senior sales engineer. I live in North Carolina, just east of Raleigh, obviously working from home, just as everyone else is. So let's go ahead and jump into this, just talking about securing remote workers. So there was a time, and many of you remember this, when we actually went into an office to work. And the thing about being in the office was you had built your security based on what's commonly referred to as the castle in the moat. So you have this hub and spoke model where everything flows through the data centers and then goes out, egresses out to the internet. IT and network spent a lot of time and efforts on that perimeter to protect the employees, keep the data on the inside, and keep the bad stuff out. Then there was this introduction of laptops and mobile devices, which allowed us to be able to work remotely. So we used to be able to work from a cafe in between sales meetings and other types of meetings, whether it be Starbucks, could be working on a plane. Some had the luxury of working on a beach. So if you had good LTE or 5G broadband connections, then you were able to work in remote locations like this. Perhaps even social distancing in a park or a beach now. Then this is really our current state. Now, I don't know if it's everyone's current state, having a dog next to you and sitting on the sofa. If you are, most likely you're looking at TV, watching TV, really not working. But this may be more common of what we're doing. We have our kids at home now. So we were just talking earlier where someone needs to start working on fractions in a little bit. Schools are starting this whole online trend. Some are really good at it. Some are not so good at it. My daughter's in the other room right now and she's working on her Chromebook. So needless to say, our lives have drastically changed. We're all consuming the home internet bandwidth. So let's go ahead and just take a look at some charts here. And what you can see, this is from our Netskope threat labs and sort of charting the remote workers. And obviously you can see there's some spikes during Thanksgiving, Christmas, New Year's. So certain holidays, you'll bring your devices home, you'll probably get online, go to some cloud apps, go to some web apps, check email, etc. But then you can start seeing this whole hockey curve of going up once COVID-19, named by WHO, and really started this drastic curve of remote workers. So if we look at the different places that people could work from, the real question that we need to ask is, can we detect or differentiate where people are coming from? They come in from an office, they come in from home, or are they coming anywhere in the globe? And really the key is, what if you had a way of looking at the applications that users were going to, whether it be cloud app, web app, private apps, and to be able to give that same security posture as if they were actually sitting inside the defined walls of an office. So let's go ahead and take a look at where users tend to go. Websites. We've been going to websites for years and years. That's never going to stop. So those are common places when you first fire up your laptop or your mobile device, you go to a website. But then there's also cloud apps that users are going to. So then the question becomes, how do you differentiate a cloud app versus a website? So let's take CNN, for example. So CNN, typically you probably classify that as a web application. However, it does have a login. You can post data, you can download data. And typically when you think of cloud apps, you think of a login, uploading data, download data, sharing data. So the lines have become blurred or cloudy, pun intended, between what's a website and what's a cloud app. So then when you start really breaking this down, what we're seeing is the highest percentage of where users are going and the traffic that they're taking the internet to are cloud apps. And then finally, you have private apps. Now, these private apps could live in your corporate data center, or if you're a little more cutting edge, you could be developing these private apps in Azure, GCP, AWS, et cetera, and hosting these private apps actually in the cloud within those IaaS instances. All right. So we know three things. users are going to websites, cloud apps, and private apps. Now, the thing is, with the websites, we already mentioned there's risky sites, there's good websites to go to. So you can do some basic blocking and tackling there of URL and content filtering that you're probably used to if you have an on-prem secure web gateway, or even doing some of that activity at an on-prem firewall. But again, when the users are off network, how are you controlling what websites they're going to, especially if you're not VPNing them back in and flowing this traffic through the corporate data center. But then when you start taking a look at the different cloud apps that the users are going to, but what about the private apps? So let's focus on the right-hand side for a moment. So you have private apps that can live in data centers as well as in the public cloud. So we're all remote today, so we'll all be classified as this remote worker. But users want to go to these different areas of websites, cloud apps, and private apps. So how do you safely enable those users to go to those apps without the risk of data, without the risk of threats, and the whole other gamut of things that are going on today? So let's look at private apps, and they're hosted in two different areas, whether public cloud or the data center. So to bring this into a little bit of context, we're going to play a little game here that I just made up called remote access. And these cards are going to depict 4 different categories, one being security, user experience, complexity, and admin burden. And then we're going to give them a ranking. We can use a lettering scale of high, medium, low, or we can use a number scale. So I'm actually going to use the number scale, but you can see how that ranks back to high and low. The ultimate goal here is to minimize complexity of the deployment and the admin burden while increasing security and user experience. So here's a sample of what the card may look like. We'll have remote access, and then we'll give a number score for security, user experience, complexity, and admin burden. Okay, so let's go back to this scenario here, and we'll play that game while looking at the traditional tools for accessing your private applications remotely. So if we go ahead and pull that card, when we look at remote access VPNs, this is the most common form of remote access we see, and it's where we have the VPN client on our machines. So then the users now connect to a VPN concentrator, which is sitting back inside the data center. So now they can start granting access to the actual network. Now some have multi-factor or two-factor authentication or step-up authentication if they're trying to enhance their security posture. But the biggest security issue with this whole thing here is if we look at the blue lines off the VPN concentrator, once I VPN to the network, I can move laterally throughout the network. It's just like I'm on-prem. So I have access to the entire network stack. So what if I was a malicious user or the account was compromised? Now I can move laterally inside the network environment, exploring all these different applications, network drives, whatever the case may be. So if you really look at this approach, it kind of seems insecure because we really want to operate on the principle of least privilege, not have an implicit trust. So if we're going to go ahead and give this a score, we can rank security as a 3. So, basically if we're going on a scale from 1 to 10, from a security perspective, it's a 3 because of the broad level access, which results in risky lateral movement. The user experience out of a 10, we'll give this a 6. It's more so in the middle of the road. It's not awful, but they still have to sign in every time they want to access corporate resources. But then when you start looking at the complexity and the admin burden, it's right down the middle. So IT and security staff have been deploying VPNs for years and years and years now. So from that perspective, it's sort of what they're used to. Now, what about remote access to private clouds? So if we take a look at the same remote access VPNs, now, since you can't take an actual physical appliance and upload that into a cloud environment, we're running virtual instances and things like that. So let's take AWS, for example. So if you want to start hosting private apps there and you want to securely access those, you can apply some type of virtual appliance or software inside that environment, which is a new VPN profile that the user needs to use. Now let's take that a step further. Now they're going into Azure, now they're going into Google. So now you have many different VPN profiles that the user may need to use and determine which one to actually utilize to access the appropriate resource. So if we take a look at our card now, we can see that security has actually gone down to a 2. So it's actually harder on security. The user experience is really awful because now the user has to determine what VPN profile or client do I need to utilize to access the appropriate resource. And then the complexity and admin burden go up exponentially because now they have to manage more VPN solutions and making sure that they're giving this information to the right users so that they can access this information. So now another way of doing it is having that public or that private app just easily accessible from the remote workers. Obviously not very secure, but the remote workers are happy now because they don't have to think about what VPN profile to use, and they can access this application, these applications directly. But that also introduces the risk of other users, not part of your organization and company, that can access those same types of cloud apps if they have the IP address or the domain that they're accessing. So now you're having this outside risk and outside influence that could negatively impact your private apps hosted in the cloud. So when we take a look at a card for this and how we want to stack rank this, obviously security is not very good because it's open to everyone. The user experience is actually quite high because the users don't have to worry about what VPN profile to determine which one they actually want to use. The complexity and admin burden is kind of low because they've just opened it. But again, let's go back to security. It's very insecure method from this approach. So as we start talking about different publishing apps and different things, we've all heard about the leaky buckets from AWS. So we see this all the time. But things are exposed publicly, then you start making the news, which we don't really want to be making the news as to saying that a S3 bucket was wide open to the world, or misconfigurations within AWS, GCP, or Azure environment. And really, it seems like S3 buckets were the #1 causes of data breaches last year. So you can constantly see this. And I actually just saw a newsletter today. I was going to bring in some of those images, but I just ran out of time. There was about 3 articles today on still S3 buckets that are wrongly exposed. So that issue, unfortunately, is not going away. Okay. Another option is hairpinning, or often referred to as backhauling all the traffic back to the data center. So now I'm not sure what approach everyone's using today, if they're doing split tunneling or VPNing just to the critical apps and then letting the users go to the internet by themselves, or if you're actually VPNing or backhauling all that traffic back to your data center and then pushing that out. The problem with that approach becomes now your VPN concentrators, and I'm sure most everyone on the phone has been dealing with this. We've been talking to a lot of customers lately about this exact scenario where the VPN concentrators have not been sized and not scaling appropriate. Some are throwing more appliances to it, some applying more licenses to it, and getting over that curve. But we are seeing a lot of business critical apps with users not being able to access that because the concentrators were not scoped properly. We never anticipated the entire workforce to work remotely. We only anticipated a certain percentage. So as we start building that out and looking at hairpinning from a card perspective, so security is a 3, user experience is a 4, complexity and admin burden is high. And then what about scaling this? So as you start adding all your different remote workers, they're hitting that VPN concentrator. So now the complexity is right in the middle of the road, but the admin burden is through the roof because now they have to maintain these VPN concentrators, make sure that they can handle the workload that's coming in, possibly purchase new appliances, whatever the case may be. It's about trying to scale something that was never meant to scale. So let's take a look at what Netskope Private Access offers from this perspective. So to simplify the approach, what we can do is when we look at remote workers, if they have the Netskope client installed, so just think of it like a VPN client. It's a steering client, but it also gives access to private apps. So you can replace that VPN client, replace it with the Netskope client, and what that allows them to do is securely connect to the Netskope cloud. And then from the Netskope cloud, they're able to connect to what's called the Netskope Publisher. So the Netskope Publisher is a virtual appliance that can be installed on premise. It can be installed in public clouds. We have images in the AWS and Azure and GCP stores that are already pre-built, and you can deploy those in a matter of minutes. I had a customer do that not too long ago. They called me and said that they were running into an issue accessing their Oracle HR and a handful of other apps. And within less than an hour, we had them connected to those apps that were living within their data center. So you install the publishers in the public cloud. So now the users, the remote workers, have that seamless connection of access to the given applications and not the entire network. So what the publisher does is it says, what application should the user have access to based off who the user is or based off AD groups, and then serve up those applications when the user requests that resource. And what I'll do is I'll show you what that looks like here in just a second. So if we give this a score, you can look at security and user experience as very, very high because it's secure going through the Netskope cloud. The user experience is great because they don't have to worry about what VPN profile to utilize. And now they're using one single client to connect to multiple public cloud apps, as well as their on-premise data center. And then the complexity and admin burden is extremely low because once you deploy the publisher, you just define what apps and what groups, and you're off to the races. So let's go ahead and see what this looks like in a live demo scenario. So let me stop sharing. And then I'm going to share out my desktop now. All right, just want to make sure that everyone can see my screen.
Not yet.
Give me 1 second, maybe I didn't.
Just a quick reminder, if anyone has any questions, you can feel free to put them in the chat session or the Q&A and we can get those answered. Yep, now we can see.
Okay, perfect. All right, so let's take a look at a couple different scenarios here. So one scenario is that I'm hosting Splunk in AWS. So I want to access my Splunk application. You can see I'm hitting a 10 address, so I'm hitting a private address here, and right now my browser is just spinning. So let me just go ahead and stop that for a second. Another scenario that I have is hosting a WordPress site. So, I have this publicly facing, so I'm using a public IP range here, and users can come in and can go ahead and post to the boards and whatever the case may be. But as an administrator, I may need to, log in and update the WordPress site or actually SSH into the environment in different scenarios. So as soon as I hit the login, you can see that I don't have permission to access this site. So these are all different things that we can hide behind the presence of Netskope Private Access. Let me just show you one more thing, then we'll show you how we can connect to those. So if I want to go to a SSH session, you can see that I cannot resolve the host name, the 1010 address. So let's go ahead and just enable the Netskope client. And as I said before, the Netskope client is doing much, much more than just giving access to private applications. It's controlling web sessions and access to cloud apps, and we'll show some quick examples of that later on. But so let me go ahead and do a quick refresh here. And now you can see that I have access to the login page simply by enabling my Netskope client. If I come back over here and do a refresh on my Splunk app, log into Splunk. now I'm presented with the Splunk login. You know, obviously can log in and do whatever work I need to do. I guess as a plug for Splunk, there is a Netskope app for Splunk. So a lot of our customers utilizing Netskope will take the feeds from Netskope, and Splunk will pull those events into the Splunk application. And then the last scenario here is the private access to SSH. And now you can see I can easily access SSH. So what this really looks like here, I'm going to go ahead and just disable that. I'll log into my Netskope console. And it's really defined about policy. So what we're doing here is, let me scroll down to NPA. So I have a couple private access policies. I have allow WordPress admin for SSH, admin access to the website. I can even grant network access shares. I can do RDP access and Splunk access. So there's several different ways. And basically the way it works is regardless of port and protocol, you can define that port and protocol range and really just lock that down. So what a policy really looks like here, really simple. I'm defining who the user is, or if I wanted to pull in user groups, I can do that as well. I'm defining the private app that I want the user to have access to. So as I start building out the apps, I can start selecting those here. And then I can also tie this into device classification in the OS, so I can make sure that they truly are coming in from a managed device and not just the presence of a Netskope client. So I could be looking for like a CrowdStrike executable running, or maybe a certain certificate, or some other things that are running on that machine to determine that truly is a managed device versus just something running the Netskope client.
Ryan, there's a couple of questions that are coming in.
Okay.
Okay, you want me to interrupt you? I know you're kind of on a roll here.
No, that's fine. Sure.
Okay, and then if it's coming up, you can just tell us to hold on to it.
Yeah, you bet.
Can we force all connections through the Netskope cloud?
So probably need a little bit more context on that question.
Okay.
But let me answer this high level, and then if we need to drill in a little bit more, maybe can just post a follow-up. But the way Netskope works is we can take either all the cloud apps, private apps, and push those through Netskope. Alternatively, we can take all web traffic, anything destined for 80 and 443, push that into the Netskope cloud platform where you can manage your policy enforcement as well as your private apps.
Okay. And then one last follow-up here. What is the encryption standard method being used to ensure secure connectivity?
So the encryption, varies from where we go, but it's all using, the normal standard SHA-256, AES 256, depending on if we're doing file level encryption or hosting that TLS connection. So everything is going securely to the Netskope cloud. Obviously, when you start looking at the different applications, most of them are TLS or SSL encrypted. I think the last stat from like Google was around 92% of websites now are using some type of SSL. So we can securely take that traffic and then through the Netskope platform, cloud security, inspect that SSL traffic all the way down to who the user is, understanding the activity that the user is performing, analyze the data and even look at it for DLP, as well as threats. And then also even taking that one step further and understanding the application that the user is using. And I'm going to talk about that here in just a moment.
Okay. Yeah, I think he, and a follow-up on the first one was corporate laptops with no access to the internet without going through Netskope.
So again, we can, anything going through the browser, destined for 80 and 443, we can steer through Netskope.
Thank you for taking the time there.
Yeah, you bet. Cool, good questions. And if anything's unclear, we can always, follow up offline too if we run out of time. All right, so let's go back into the slide deck here. Just a couple more slides. So let me. Oh, the last thing I was going to show in the UI here is so that's how you define your policy. So if I go into Security Cloud Publishers, this is where I can define my Netskope publishers that I want to use. So whether it's on-prem or sitting in a private cloud environment. And then under the custom apps is where I define my apps. So here's where I can say, well, here's my Splunk app. This is the host IP, where it's actually sitting. Is it reachable? Is it used in policy? And am I actually steering this content? So it's just a matter of saying new private app. You give it a name, the host, TCP, UDP, you select the publisher that you want to use, then a secondary publisher, and you've already defined your app. So it's very simple and very easy to define. All right, so let me come back into the Prezo. All right, can everyone see my screen correctly?
Yes.
Okay, perfect. All right, so back to this diagram that we were showing earlier. So again, you have the remote workers utilizing with the Netskope client. So not only are they following the blue line for the private apps that you can see, so based off the publisher and what apps they have access to, but they can also follow the orange line in giving access into the cloud apps as well as different websites. And this is part of our next-gen secure web gateway. When you look at traditional secure web gateways, they really don't have an understanding of the cloud applications. And the reason being is they were built as appliances and built for on-prem. And the whole language of the internet and the way cloud apps work has changed. It's no longer static HTTP, it's no longer static HTTPS, where we're now dealing with APIs and JSON, and Google didn't like JSON, so they came up with protobuf. So we have all these different languages that we need to understand, and that's really where Netskope excels in understanding the language of the internet and to be able to determine what is an upload, what's a download, what's a share activity, and then really getting down to the root of the data, where that data is flowing, where is it going, and should it be staying in a certain applications. So we can utilize DLP policies to make sure that data is not going into an incorrect repository, such as a personal box versus a corporate box instance. Sorry, I already built that out without building it out. All right, so the next scenario that we're going to talk about, if we focus in a little bit on cloud apps, is with the remote workers. Again, going through the Netskope Security Cloud, accessing the cloud apps, oftentimes they're uploading sensitive data into these cloud applications. So if we take a look at the cloud apps as IT-led or managed by your corporate, it could be Box, it could be Office 365, it could be Google, Salesforce, Slack, Teams. We're seeing a huge influx of Slack and Teams being utilized as well for collaboration and communication. So many different areas of IT-led applications that sensitive data and data is flowing in and out of. So if sensitive data is going into this repository, do we want that sensitive data that's living inside of, let's just use Box for example, Box account to end up on a personal device? Hopefully the answer is no, because once it lands on a personal device, now you've lost control and context of that data and then where it can flow, and it's easily exfiltrated from that perspective. So what we can do is integrate with an IDP, so a single sign-on solution such as Okta, ADFS, Ping, and basically anything that supports SAML 2.0 for the home workers. So now that we're classified as remote workers, but we're also home workers as well. So I have a laptop behind me, I have another laptop, but it's not a corporate laptop, it's my own personal. So how can I successfully or securely access my IT-led applications such as Office 365, Box, Google, Salesforce, et cetera? And as long as those applications are front-ended with this single sign-on solution, we can integrate with that technology partner to provide security. So what that ends up looking like is, giving that full experience for the next-gen secure web gateway. So let's go ahead and just jump into another live prezo here. So my Netskope client is disabled. So again, I'm going to be acting as I'm a untrusted, unmanaged device. So what I'm going to do is just bring up a new browser window here. And I'm going to log into my IDP, which in this case is Okta. So from the user experience, this is great. It shows me what applications I have access to. So I have ShareFile, Mail, and Box. Let's just go ahead and click into Box here. So what ends up happening now is two things have occurred. The IDP has handled the authentication and trust of the user. So one, do you trust who the user is coming in? So they've already trusted the user. They've entered the correct credentials, and now they are accessing the application securely through Okta. The other thing that just occurred now is Okta did a handoff to Netskope, and now we're looking at the security posture of the application and of that user and determining where is this user coming in from? Well, the user's coming in from a remote device or an unmanaged or an untrusted device. So we're going to send them into what's called the reverse proxy. So this is basically just a URL rewrite that occurs from IT-led applications. Now Netskope is in the middle of this transaction and can see the activity of the user and still apply policy enforcement. So for example, if I'm part of HR and I want to start onboarding new employees, which probably isn't happening a whole lot right now, even though on LinkedIn I did see a couple of my friends start new roles, so maybe there are still some hiring going on. But from this perspective, I'm part of HR. I need to onboard new employees. So what I want to do is I want to download this file, coming in from an unmanaged or an untrusted device. So two things just occurred. I tried to download the file. So number one, we stopped the download from occurring because it violates our PII policy because the file has names and social security numbers in it. But I'm also coaching the user and letting them know why they cannot download this file because they're coming in from a non-managed corporate asset. So from that perspective, I'm keeping the file in the repository where I'm expecting it, and I'm preventing the loss of that data. Now, another scenario, I can be less restrictive if they're trying to interact with, say, release notes or maybe a menu to their favorite restaurant that they want to download. So if I go ahead and try to download these release notes, we have integration with Okta as well as RSA, and others are on the roadmap to do step-up authentication. So what this allows me to do is, hey, are you really who you say you are? So I'm going to go ahead and click OK. I'm not mirroring my phone, so just give me a second. And once I get that, I'm going to say, yes, it's me. And once that request gets back to the message, you can see the release notes have been downloaded. So now I'm saying, are you really who you say you are? Doing step-up authentication, validating the user, making sure that those credentials haven't been compromised. And I'm getting that because I clicked OK twice. Again, another way to securely make sure that the data is staying inside the repository. If you're being a little less restrictive, you can force step-up authentication. We have some customers where, regardless of content, they just don't allow the download. So that's another approach that you can take. Several different ways to secure your environment. Now, one other thing I was going to show quickly is I'm going to flip over to another device here. That's a managed device utilizing the Netskope client to steer traffic. So let me bring up a browser. How are we doing on time, by the way?
Fine. We, I think it's, what time is it? 11:42. So you have until noon.
Okay. All right. Perfect.
That's when the bar opens up anyway.
Sweet. All right. So let's just take that same approach that we just took earlier from an unmanaged device going into Okta. So I'm going to go ahead and log into that same portal, same three applications. So I'm going to click on Box once again. maybe make that a little bit bigger so folks on the phone can see it. Now this time, when we look at the URL, I do not see our proxy.ghostscope.com. So we're smart enough to know and to be able to detect the way that the user is coming into this application. So the presence of the Netskope client, again, is one way to determine if it's a managed device. I showed you device classification earlier. So those are other ways that you can really increase your posture to make sure that they're truly coming in from a managed device. So if I go now and try to download this new employee data file, I should be able to download it just fine, assuming I have other compensating controls on my device where I'm not going to actually lose that data. I'm able to download it, work offline, re-upload it. Perfect. So what if now I want to, actually, instead of even doing that, let's just do this. So I'm not logged in. I'll do it this way here. So let me log out. Of my box as well as my Okta. So now let's just go to app.box.com. So most of the time when you access an app like this, it's some type of URL like app.box.com or drive.google.com or portal.office.com. I think you guys get the idea here of there's all these vanity or these generic URLs that users go to. But this time I'm going to log in with personal credentials instead of corporate credentials. So let's go ahead and log in. And now let's go grab this file. So I'm going to say show in folder. And let's just take and drag and drop this, if I can grab it correctly, and move that into my personal Box account. So what just happened is I pissed off the rock. Typically not a good start to your day doing that. But I'm also preventing the loss of this data going into a personal Box account. So what I'm able to do is differentiate the instance of Box. So corporate instance, partner instance, personal instance, same thing across O365, Google, Slack, Teams, etc. So we are instance aware to determine the application that the user's utilizing and making sure through policy, data is only going into the correct repository. So another quick example that I can show here is if I go to this app called, actually, let's even do something else. Let's go to Amazon. So I'm sure a lot of individuals here are using Amazon. If you're a Prime customer, which probably most are, let me just sign in, see if I'm going to get, well, I guess I'm not going to sign in there. So basically part of Amazon, you have Amazon Drive and you have Amazon Photos. So if you're a Prime customer, you actually get access to a bunch of storage. What we're able to do with the next-gen secure web gateway is allow users to go to Amazon, allow them to add items to their shopping cart, but don't allow them to use Drive, don't allow them to use Photos because that is a threat vector. So here's another example of just a cloud storage app, looks super enterprise ready, Zippy share. So I can control things like the login and say, wait a minute, this is a risky cloud app. And this is based off of our cloud confidence index that we're tracking over 36,000 apps today, and determine the enterprise level risk of these applications. And if they're risky to the organization, I can automatically steer the user away, coach them, but then redirect them back to the application I want them to use, in this case, OneDrive. So I got 2 more slides and then we will wrap this up. So going back to this picture that we saw earlier, so yeah, the remote workers, accessing websites, cloud apps, private apps, depending on where the users go when they open up their devices. But now we can also add in personal devices, and that's that gray line as they're going to sanctioned led cloud apps. can still allow them to have access to those IT-led apps, but also protect the information and ensure that it stays inside that given repository. So if you look at really what we're talking about Netskope and how it can help in security consolidation, so you can take the private access, the secure web gateway, DLP, threat capabilities that we have, and consolidate this all into one single platform, one single policy engine, one single Netskope client. So you don't have to deploy several different policy frameworks, different steering clients, or different endpoint components to manage this. And you don't have to look at different security web UIs to actually manage all these individual policies. And as we start looking into the future, if you've heard of the term SASE, Secure Access Service Edge, so this is something that Gartner has come up with last year, and we really fit well into this mold. So the prediction around SASE is where you're taking your entire security stack and network stack and delivering it in the cloud, and which is really represented in this diagram here. So you have the capabilities like DLP, secure web gateway, UEBA, browser isolation, DNS, SD-WAN, all these different areas, and you can think of those as different services that can be plugged in to an individual concept to adhere to the SASE methodology that Gartner's coming up with. So I will just leave you with one, if there's any questions, we have some time for those. Thank you, but there is a cloud security for remote workers ebook that's available from our website.